Ayan. Hello, good afternoon, guys. So, we're done with chapter 2 last meeting. We finished chapter 2 sa topic na conductors and capacitors. Tinignan natin yung energy and ano yung difference kapag conductor versus charge distribution. Okay? Nalaman natin na sa conductor, sa loob ng conductor, dun sa thickness ng conductor, yung electric field mo dun, zero. Okay? Sa chapter 2 din, napansin natin na yung electric field natin can be written as this. Okay? Tapos, napakahirap niya gamitin, di ba? Mahirap gamitin itong definition na to. So, we discovered different ways to solve for the electric field. We had the Gauss's law na relatively much easier basta may symmetry yung system mo. Okay? And then we found out that we can also find potential, V, as given here. Okay? Tapos, mas madali ito kasi nawawala yung direction na vector mo. Okay? No direction. No direction. Okay? And then, sa Gauss's law, sa differential form ng Gauss's law, kasi di ba kinuha natin yung divergence ng electric field. We have the del of E. Okay? Del dotted with E. Pansin natin that this is just equal to rho over epsilon naught, or yung usual definition natin ng Gauss's law will be the integral of this all over some volume tau over epsilon naught. Integrate natin ito dito. Tapos ito ay Q enclosed. Diba? Q enclosed over epsilon naught. Okay, this is your usual Gauss's law. Okay? Okay. So, tapos nalaman din natin that you can write the electric field E as something like this guy. Okay, the gradient of the potential. Kaya mas madali kaya natin naisip na mas madali kumuha ng potential kasi from the potential pwede mo na makuha yung electric field. Okay? So we have this from the last chapters. Okay? Dito. So from this, tingnan natin kung anong mapapala pa ba natin with this. Pwede natin combine itong dalawa. Okay? Pwede natin plug in itong si E dito sa divergence natin. And we will actually have something like the divergence of the negative of the potential. Okay? And that is equal to rho over epsilon naught. Okay? So, pinlog in lang natin itong si E doon. Okay, no? And then, kung maalala nyo, kung nagbasa kayo ng chapter 1, yung divergence ng gradient is actually called the Laplacian. And that is given by this guy. Laplacian, epsilon. And mas magandang tingnan kung ganito. Negative rho over epsilon naught. Okay? So that's that. So tingnan kung bubuklatin yung likod ng libro nyo, yung Laplacian in the Cartesian form will be like this. Okay? Itong left-hand side. Okay, so itong equation na to, is called the Poisson's equation. Okay? French si Poisson. Okay. So, ganun yung pronunciation. Okay, so titignan natin ngayon yung silbi nitong equation na to. Kapag pumunta tayo sa mga boundaries or sa mga regions na walang charge. So, pag walang charge, wala namang mangyayari. No, ang tinutukoy ko is, kunwari meron kang charge dito. Meron kang charge dyan, positive, yan, kunyari ganyan. Okay? May charge ka dyan. Pag tinignan mo ngayon yung region, in this area, wala kang charge dito sa loob, pero may nararamdaman kang field, may nararamdaman kang potential dahil dito sa charge na ito. Okay? So when we do that, we're actually using Laplace's equation, which is given by this. Okay? So dinidefine niya tong region na yan. Kasi walang charge distribution sa loob. Okay? So when we talk about this equation, pwede natin tinitignan itong part na to. Kasi meron siyang charge. Siyempre ayaw natin yun. Ang hirap i-solve nito, di ba? Kung nag-math, hardcore math na kayo. Mahirap to i-solve. So punta tayo dito para mas madaling i-solve, di ba? Ito kasi may particular solution. Ito kasi homogeneous solution lang. Okay? Okay, so tingnan natin tong part na ito. Tingnan natin kung anong properties na pwede natin madakot dito sa equation na ito. Okay, so hindi tayo magsasolve. Titingnan lang natin kung ano yung tsura nun. Okay, tingnan natin yung one-dimensional case. So hatiin natin to. Kuwari ang equation mo lang ay dependent of x. So we have this equal to 0. Tama? Okay? And this is fairly easy to solve. Okay, so this is the solution for this is trivial. Sana trivial for you guys. So it's just actually mx plus b. So where m and b are arbitrary constants. Okay? Tama, di ba? Pag dinerivative mo to twice with respect to x, ang mangyayari ay magiging m, then v. 0, di ba? Kasi derivative nito, 0 lang din. Ay, constant lang siya. So, pag derivative mo, mawawala siya. Okay? And this is, again, ayun yung solution niya. Okay, so, let's try to graph this thing. So, we have a line. Suppose na yung line mo ay something like this. Okay. This is your v of x. Oh, sorry. V of x. Okay, guys. Okay, so, pag kinuha natin kuwari, this is x naught. X naught. There is at this point, may meron kang corresponding potential v of x naught. Tama? Okay? Makes sense, di ba? Kasi ito ay x, ito ay v of x. Okay? 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 So, malinaw pa naman, di ba? Malinaw pa naman. Okay, it is intuitive na kuha tayo ng space at this point and at this point. So, this is x naught plus a, and this is x naught minus a. Okay. And correspondingly, meron kang value at this point, which is v of x naught plus a. And correspondingly again, at this point, meron kang makukuha v of x naught minus a. Tama? Diba? Fairly simple naman. Okay, so with this, since linear naman siya, you can actually get what v of x naught is. And that is the average of v of x naught plus a plus v of x naught minus a. Okay? Okay, parang sir, parang napaka-intuitive naman yan. Sir, ano ba makukuha namin dyan? Okay, so wait lang. Going back. Ay, naglalag ako. Okay yan. Okay. So, ayan, no? Napansin natin na when we have the solution for the Laplace equation, yung potential at any point will just be the average of the points that are equidistant to it. Okay? Ibig sabihin nun, pag kumuha tayo ng point at any point x0, makukuha mo yung v of x0 by just taking the average of the points or the values around it, which is x0 plus a and x0 minus a. Okay? Okay. At this point, mapapansin din natin that the local, so what is ibig sabihin ng local, these guys, at these points, the local maximum and local minimum is just at boundaries. Boundaries. Ano ibig sabihin nito? Yung maximum mo and minimum can only be found at this. Okay? So, the minimum mo ito, yung maximum mo ito. For the region, x0 minus a going to x0 to a. x0 plus a going to x0 plus a. So, at these points, siyempre straight line lang yan. Hindi naman pwedeng gumanon yung drawing mo. Diba? Kasi line nga tayo, hindi na to line. And kapag tinignan mo yung, kasi pag tinignan mo yung points dito, meron kang local minimum, which is this, diba? Okay? So, hindi pwede. Dahil straight line na lang, yung boundaries mo will actually be located at your boundaries. Okay? Okay, very straightforward naman. Now, we consider naman natin yung two-dimensional. And that is x squared plus derivative, second derivative, with respect to 1. Okay, so tapos equal to 0 kasi Laplace equations pa to. Okay, ito, hindi natin siya muna isa-solve. Okay? But this tells us, similarly, that for a surface, let's draw a surface. Yan, surface yan. So, yung tsura mo, ganyan. Kung na-imagine mo. Mukha siyang bacon. Okay? Ito mataas, ito. Okay, mapansin mo that if you create a patch here, say create a patch, circular patch, okay? Mapansin mo that again, yung local maximum mo at minimum mo will be found at the boundaries. So yung maximum mo nandito, maximum mo na dyan, yung minimum mo nandito. Okay? And we can actually write down that the potential at any point xy can be written as this. So 1 over 2 pi r, i-integrate mo yung v dl. So hanapin mo ngayon yung potentials at this point. Circle mo, hanapin mo yung potentials dyan. Isisum mo lahat sila through the integral dl over the circle, then you divide that by a circle. In essence, you're taking the average of the potentials on that boundary. Okay, you can actually make a square. Pwedeng pa-square yung, sorry, pangit ang drawing. Pwedeng pa-square yung close integral mo. Square. And you can actually divide it by 1 over, say, s squared. Kasi square tayo, diba? You can actually have this, but this is, again, complicated. You are complicating your life. So, mas madali na kumuha ka ng patch na circle. Okay? So, that continuous lahat yung sides mo. Okay? So, we're just taking the average. Again, wala tong local maximum or minimum. Okay, sir, parang ini-scam mo naman kami na bakit walang local maximum or minimum? Okay, let's take a pause from that equations and look at isipin natin muna kung ano yung shape ng mga potentials natin. Okay? So, let's take this guy. Okay, so this guy is Earth. Okay? The potential of Earth, V of Earth. V Earth na lang. V sub Earth. Can be actually graphed as something like this. Put tayo ng ibang color for the graph. Okay? Tapos yung potential mo, let's graph that in red. Yan. Okay, so the red one is your V. Okay? Okay? So, anong point ko dito? Okay? Wala, ikaw ay isang tao. You stand here. You stand far away from Earth. Okay? What do you feel? Wala kang mararamdaman, di ba? You're floating in space. Okay? So, kuwari, tumayo ka dito. So, para ka lang nasa flat ground. Wala kang nararamdaman na anything. However, if you stand near enough Earth, okay, stand here, or you stand here. Ito yung real life representation na nasa taas. Real life. Real life. Okay? Okay. So if you stand here, near here, ang mangyayari sa'yo is hahatakin ka pa loob sa Earth. Similarly, kung titignan mo sa graph, itong tao natin dito will just fall towards the hole in the potential. Okay? Similarly, if we have real life charges, let's say green, and this is a real life charge, negative. Hello, sorry. Naputol ako. Saan ako naputol? Nawala na ako internet bigla. Hello. Naririnig na ba ako? Hello, sorry. Naputol ako. Saan ako naputol?
Sir, yung nahulog sa hole.
Okay. Okay. Sige, balik tayo. Sorry, naputulan ako ng internet. Bad trip yan. Hirap to. Malinaw ba ako ngayon? Okay, okay. Sige, share screen na lang ulit ako. Sorry. Okay, ayan. Kita na ba? Thumbs up kung kita na. Okay, thank you, thank you. Sorry, ulit naman. Naputol lang internet. Sana hindi na maulit. Globe, ayusin niyo buhay niya, Globe. Okay, dito ako naputol. Okay, okay, ito yung tao natin. Pag lumapit siya sa Earth, di ba? Atakin siya paloob. And similarly, kung i-graph mo yun sa potential, pag tumayo ka malapit sa pababa, atakin ka rin yun. Okay? So yung potential natin is somewhat a representation of how things move. Okay? So let's say we have this. We have a charge, negative Q. Negative Q. So when we graph this, ito na yung potential. Similarly, the graph for this potential is like this. Like this. Okay? So when we place a charge Q here, positive, ano mangyayari kay positive Q? Pag malayong-malayo siya, it will just stay there. Okay? However, if we add this guy near the charge, kung naglagay ka ng somewhere here, ang mangyayari, mahuhulog siya pa ganun, and in real life, ma-attract siya kay negative charge. Tama? Kasi negative attracts positive. Okay? So in this region, kumari kumuha ka ng region na to. Kumuha ka nung region na to. Okay? Meron kang local minimum or maximum. Okay? At this boundary, you can say na ito na yung maximum, ito na yung minimum. So the Laplace equation, since it is a zero, this tells us that yung pinipili nating region is walang charge. Kuwari, walang charge. So yung potential doon, V, kuwari pa ganun, nandito yung charge mo, Q, kasi ito na yung potential ng graph mo. Pag kumuha ka ng region, at the point na walang charge, kunyari dito, mapapansin nyo na yung maximum or minimum, nasa boundary lang yan. Okay? Kaya yun yung pwede nating isipin for these guys. Okay? Okay, next, yung 3D naman natin. Again, ito na yun, yung Laplace equation natin for 3D, XYZ, or pwede natin express yun in other coordinate system. But then again, it's like this. Tapos, mahirap yan i-solve. So, hindi natin muna solve yan. Mga next week pa, ganun. Tingnan lang na muna natin na similar lang din yung nangyayari. Okay? So, yung at any point V of R, the potential there, assuming na walang charge, okay? Again, walang charge sa area na yan, will just be the integral of V along the boundaries. Okay, so sphere na yun. Kung papakiramdaman mo lang yung V at that point, okay, makukuha mo yung potential doon by just taking the average. Okay, mapansin nyo dito, sphere yung ginamit. So yung surface area ng sphere, which is 4 pi r squared, yung ginamit as pang average. Okay? Okay, kuha ba yan? So mahirap to imagine no? As compared dito. Dito madali lang. Ito 3D na kasi. Okay. Okay. So may tanong ba? Naguluhan ba? Okay. Yan, may chat. Sir, ano po ulit mangyayari kapag may charge po sa loob ng region na kinukuhanan ng potential? Okay. Wala pa tayo dun sa part na yun. Hindi pa natin alam kung ano mangyayari actually. Itong part na to. Yung Poisson's equation. No? Itong part na yun, yung Poisson's equation. May charge sa loob pag ginawa mo ito. Okay? So, hindi pa natin siya itatakal ngayon. Tinignan lang muna natin kung paano paano yung behavior ng potential kapag Laplace equation. Okay? So far, ang nangyayari lang, at any point, kinukuha mo lang yung average ng boundaries niya. Okay? So kapag linear, pansin mo, kinukuha mo lang yung average ng potential sa x plus a at x minus a. Then kapag 2D, kinukuha mo ngayon yung average ng circle, yung potential sa circle na yun. Okay? And then for a 3D, kinukuha mo yung average ng potential at that sphere. Okay, so suppose kunyari, we have a coordinate system. Then you have a charge. Q, positive. And then you want to know what's the potential here. Okay? V. Okay? So, kuwari 3D yung problem. You can actually create so that V, so kung sabihin natin to ay Z, and we make a sphere, i-average lang natin yung potential sa sphere. Okay? So we have V, kuha na natin 4 pi r squared. Yung capital R is arbitrary kung ano lang gusto kong gano'ng kalaking sphere. As long as hindi ko ma-enclose yung charge na to. Okay? Then, we integrate that all over sphere. Integrate that. We close the integration. Lagay ko muna S. Okay, para tayo maganda. V, dA. Okay, tama ba yung formula natin? Okay, VDA. Tapos close. Okay, we know the potential of a single charge. That is 1 over 4 pi r squared. Then this is 1 over 4 pi epsilon naught r q over r. Okay, yung r mo, separation mo. Alright? Tapos yung dA mo, lipat na natin siya, magiging r squared sine theta d theta d phi. Okay? Tapos alamin natin ngayon kung ano yung r. Yung separation, curly r. Okay, paano ba yung separation ng curly r? So we pick at this point. Tapos, ito di ba, again, this V, this potential is the potential on the surface. Okay? So that's what we're getting. So yung R na curly will be this to this. Sir, wala pong square dun sa pangalawa. Anong square? Saan yung square? Ito? 1 over... okay. Tama. Walang square. Sorry. Yan. Kasi nga pala surface yung ano. Okay, so kokopihin ko lang kasi di ko pa nakopya ng tama. Napakahusay, Austin. Okay, ayan. Then we have to define R, which is this guy. Ito, gawin ko na ng green para hindi tayo mahirapan. This is R. And by ito ay theta. We know R squared is just Z squared plus R squared, capital R squared, di ba? Ito yung R. And minus 2, capital R, Z, cosine theta. Cosine law. Tama? 2 sine theta. Okay, fairly simple pa naman. Okay? Then I'll use my technique na this is 2r dr 0, 0. Tapos with respect to cosine theta na lang. So this is actually 2rz sine theta d theta. Okay? I plug in things there. Okay? So we actually have 1/4 pi r squared. Tapos, balitan ko na itong integral ko para dalawang bounds na. Ito ay 0 to 2 pi for the phi and then 0 to pi. Okay? For spherical thing. 4 pi epsilon naught q r tapos may extra r ako dito. Then, ang mangyayari, plug in ko to dito sa r sine theta. So we actually have r sine theta d theta r over z. Tama? dr d phi. Okay, so since nag-switch na tayo from theta to r, ito ay magbabago na. So this is actually so since z, itong z mo, r is always less than z, tama? Kasi nasa labas dapat yung q mo. Yung bounds nito will be z plus r, z minus r. Tama? Okay? And then, labas ko lang lahat. Q over 4 pi epsilon naught. Then, cancel. Q over z. Oops, mayroon ng q. R over z. Then, 2 pi. Dahil nag-integrate ako ng phi. Tapos, ang matitira will be integral ng t, r, from z minus r to z plus r. And this is very trivial. 1 over r squared q over 4 pi epsilon naught r over z, 2 pi. Tapos ito ay z plus r minus z plus r. Tama? Kasi z plus r minus this whole thing. So minus z minus r. So naging positive yung r. And you have cancel. And this is 2r. Okay? Which gives me 1 over 4 pi r, capital R squared, q over 4 pi epsilon naught, r z 2 pi times 2r. Okay? 2 times 2, 4 pi. Kakancel siya dito sa 4 pi na to. Okay? R times r squared, cancel na rin. Ang matitira is q over 4 pi epsilon naught z, which is exactly kung ano yung nakuha nyo sa mga previous thing na ginawa nyo. Okay? Balik tayo sa problem. Diba similar lang? So yung potential dito will be the distance z. Bali, 1 over 4 pi epsilon naught. Tapos yung Q over Z. Which is the same as actually having the problem of like this. Q. Tapos, hanapin mo yung potential here at P. Di ba? Tapos yung distance nito ay Z. Ang potential niyan will be 1 over 4 pi epsilon Q over V. Okay? So it works, no? Na kukunin mo yung average ng nararamdaman mong potential at these points. So yan yung ginawa natin. Kinuha natin yung average. So yung average ay di-divide mo sa sphere mo, surface area ng sphere mo. Tapos, total mo yung nararamdaman mong field at that surface. Okay. So ayun yung Laplace equations, no? Ayun yung feel ng Laplace equations. Sir, ang daya mo naman, sir. Okay, ba't madaya? Jello, ba't madaya itong mga ginagawa natin? May naisip ka ba?
Wala po ako maisip.
Okay, wala kang maisip. Okay lang yan, okay lang yan. Kung makapansin nyo, yung left hand side ay potential. Tapos yung nasa right hand side mo, potential din. Sir, paano ko nga malalaman yung potential? Hindi ko nga alam yung potential. Sir, bakit po pala naging ganun yung itsura ng graph ng potential? Okay, wait lang. Balik ako doon. Okay, so ang weird dito kasi, sir, ang daya mo naman na yung hinahanap ko nga yung potential tapos tatanong mo sa akin yung potential doon. Okay. So ang purpose lang nito is para ma-feel natin kung ano yung nangyayari dun sa mga sagot natin. Okay? Okay. So hindi ito useful in solving. So in the next week, isosolve talaga natin to para hindi madaya na pina-plug in mo lang din yung potential, di ba? Kasi right hand side nito potential, tapos left hand side potential. Not very useful. Okay? So ano yung tanong? Sorry, may tanong sa atin. Sir, baka off topic po, bakit po naging ganun yung itsura ng graph ng potential? Saan yung graph ng potential? Yung sa dinrawing ko dito? Dito ba? Okay. Ba't ganito yung graph ng potential? Ang potential, for a single charge, Q, okay, or negative Q, and negative Q, yung potential nito, kung kabisado nyo, will be V of X is just equal to 1 over, ito yung one-dimensional niya, 1 over 4 pi epsilon naught, Q, negative Q, over X. And pag ginraph mo yan, lalabas ay ito. Okay, actually, pag ganun yung kabila. Pero gets, yung nasa right-hand side lang tayo tumitingin. Okay, tinignan ko lang yung right-hand side. Pero yung graph talaga niyan ay pag ganun, tapos pag ganun. Okay, tama? Ayun ba yung tanong mo? So, pwede kasi nga gawin natin na ang potential nito ay R para walang ganun. 1 over 4 pi epsilon naught. Tapos negative Q over R para walang negative value si R. Laging positive lang. And yung mag-iitsura niyan will be some sort of a sink. Okay, so okay. So para siyang may butas. So ganyan yung itsura ng yung graph ng gantong potential. Okay? Okay. Going back. Now, what I want to point out from this is magkakaroon tayo from these equations, from these observations, nagkakaroon tayo ng boundary conditions. And the first, ang mga uniqueness theorems. So yung mga uniqueness theorems, ito yung mga theorems na nagsasabi na kapag logical na yung sagot mo sa isang bagay, ayun na lang yung tamang sagot talaga doon. Okay? Wala nang iba. It's unique. The answer is unique. Okay, so the first uniqueness theorem tells us na oo. Okay. 1 over mukhang yung graph ko dito pala is mukhang 1 over r squared kasi both sides ng graph is same direction. Okay. So mukhang 1 over r squared to. Pero ayun nga, ang point ko is ito ay dapat 3D. So ganito dapat itsura niya. Pero pagod tayo mag-drawing. At di ako magaling mag-drawing sa tablet. So ayun. Ganun na lang muna. 2D view. Okay. Okay, so balik tayo. Mahaba yung discussion dito ni Griffiths and nakakalito actually. Yes. Okay, so dahan-dahanin natin. And ano ba itong mga uniqueness theorem na to? Okay, so the first uniqueness theorem tells us that the solution to Laplace's equation, this guy, in some volume V is uniquely determined if potential V is specified on the boundary surface S. Okay. Okay, so let's have a arbitrary. Meron tayong arbitrary volume. Okay, meron tayong arbitrary volume. Oh. Pwede kong gawin star to or Mickey Mouse. Basta arbitrary lang siya. Kahit ano. Okay? And then, kuwari given sa atin, binigay sa atin yung potential. V surface is given. Okay? Potential is given. Now, what I want to do is to prove this by disproving it. So, sabihin ko hindi unique yung sagot. Okay, sabihin natin yung sagot dito dalawa, V1 at V2. Okay? So, suppose we disprove this unique theorem by saying that the potential inside can be two different things. That is V1, V2. Okay? And then by Laplace, since they are solutions to the Laplace equation, the Laplace equation for V1 has to be 0. Kasi di ba ito definition ng Laplace's equation? And if si V1, solution siya dun sa volume na yan, then this is true. Then we also have V2 to 0. Okay? So ito ay definitions lang ng Laplace's equations mo, which is this guy. Okay? So again, I'm trying to disprove this theorem by saying there are two. Okay? There are two potentials inside, V1 and V2. Okay? Then I say, gusto ko ngayon tingnan kung gaano kalaki yung discrepancy between V1 and V2. Kasi sabi ko, di ba, hindi naman unique. I can say that there are two solutions which are V1 and V2. So titingnan ko ngayon kung ano yung difference nila. So dinag-define ako ng V3, which is just V2 minus V1. Okay? Okay. Etong si V3, ang point lang ng V3 is makita ko yung discrepancy between these two. Okay? However, since this is true, and this is true, yung potential ko at surface is actually equal sa surface, tama? Minus V1 surface. Okay? Diba? Kung ito ay functions, then kung dinefine ko na ganito, dapat at the points that they are representing, dapat this should hold. Okay. Okay, sorry. Ano nangyari sa sulat ko? Surface. But we have said that we are given that Vs is given. Yung potential mo sa surface ay ito. Okay? Tapos, sabi natin, dinidisprove natin na from that potential na nasa surface, there can be two solutions which are V1 and V2. So V1 and V2 should be the same. Tama? Vs lang din to. And Vs lang din to. Okay? Kasi we're just given yung potential sa surface and sinabi natin na this gives out two solutions which are V1 and V2. Okay? So at the surface, ito yung mga bibigay nilang value. Okay, hindi natin alam, no? Hindi natin inside that volume, hindi natin alam if V1 is V2 equal to V2. Okay, hindi natin alam. Ang alam lang natin at the surface, since ito yung binigay sa atin, tapos ito yung binibigay natin na proof na dalawa yung solution dito, then at the boundary, they are equal. Okay? And this gives me 0. Okay? Okay. So, kunin ko ngayon yung Laplacian ni V3. Okay. And that gives me the Laplacian of V2 and minus Laplacian of... Ay, yung ginagawa ko. sorry, nalito ako. Okay. Ayan. So, alam ko from here na 0 na agad to. And I can further support this claim that each element, V2 and V1, each of their Laplacians are 0 also. So we have this. Okay? And whenever we have a Laplacian, anong nangyari? Anong nasabi natin with our equations? Yung mga ginawa natin dito. Nalaman natin na yung pag walang charge along that volume, along that boundaries, along this region, walang potential, walang charges diyan. Yung local minimum mo and local maxima, local minima and local min max is at boundary. Okay? Okay? Do you see where I'm getting? Okay. Kung ganon, kung nasa boundary lang yung maximum at minimum mo, then sinabi natin na yung V3 surface, V3 at surface is 0. Diba? Na-compute natin? 0 siya. This tells me na yung buong boundary ko, ito arbitrary volume mo, this gives off na Vs is actually 0. And if this is the local maximum, kasi nasa boundary na tayo, di ba? If this is the local minimum or maximum, then inside, dapat 0 din. Okay? Dapat 0 ang potential sa loob nito. Okay? So V3 at the surface is 0. Therefore, V3 inside is also 0. Kasi ito na yung maximum at minimum mo. Kasi all over the boundary, it's just 0. 0 lang siya. So wala ka ng minimum at maximum. So V3 inside is 0. Therefore, V1 must be equal to V2. Kasi yung define natin si V3 as V2 minus V1. And if V3 is 0 everywhere, then we have V0 equal to V2 minus V1. So, tinry ko i-disprove yung uniqueness theorems. But, ang napala lang natin is unique talaga ang answer sa loob ng volume mo. Okay? So, sa loob ng volume mo, basta given yung potential mo, V, on the surface, unique yung sagot na potential na malalaman mo at the inside. Okay? Okay. So, ganun yung explanation. Okay? So, again, tinry kong i-disprove that given a boundary condition Vs, sabi ko, 2 dapat makukuha ko dyan, or 3 or 4. Makapansin ko na pag tinuloy ko yung proof ko, or yung disproval ko dun sa yung pang-counterproof ko dun sa sinasabi niya, I will just arrive at the uniqueness theorem. Okay? Ang sinasabing, isa lang yung mag-exist dyan. Okay, let's try another example. No? Show that the potential is constant inside an enclosure completely surrounded by a conducting material, provided there is no charge within the enclosure. Okay, so yung statement na provided there is no charge within the enclosure, sinasabi na yung Laplace's equation would hold. Okay? So let's say na we have an arbitrary potential again, arbitrary space again, or volume. Okay, so meron tayong ganyan. Then we are told that there is a conducting material, so a conductor surrounding that space. So this is a conductor. Okay, this is a conductor. So cavity to, no? Okay, cavity yan. Conductor yan sa labas. And then, hanapin daw natin yung potential sa loob. Okay. Okay, what is the electric field at this point? What is the electric field at that point, Eliza?
Sir, hello po.
Yes, an electric
Ano
field.
po yun, sir? E-field inside?
At this point.
Zero po, sir.
Okay, dito sa point na to. Tama, no? Zero yan sa point na yan. Kasi, go Eliza, tuloy mo. Kasi,
Dahil wala po siguro charge. Di po
Okay.
ako sure.
okay. Hindi siya sure, pero ano natin, ang rason natin bakit zero yung field dito, kasi ito ay conductor. Tama? Okay? So, zero yan at these points. 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0. Okay? So, zero yan sa loob ng mga conductor mo. Okay? Kahit anong mangyari, zero yan. Okay? So, zero. Okay? At this guys. Zero yan. At conductor. Okay? Ay, mali pala. Dapat ito ay electric field. Sorry. Ay. Ito ay electric field. Diba? Okay. So, when we get at the surface, dahil conductor pa rin yan, we'll get the, tawag dito. Since E equals 0, ano yung definition ng potential natin in terms of E? Di ba? Negative del of V is equal to 0. And anong value ni V kapag ganito? So, it is some constant, V naught, di ba? So, V can be something that's constant. Pwede siyang 0, pwede siyang 1, pwede siyang 2, or something else. Basta ang point is, kapag dinerivative mo to, ang makukuha mo ay electric field equals 0. Di ba? Dahil nga nasa conductor tayo at this surface. Okay? Okay. So, along the surface, all along the surface, the potential is constant. Then again, sabi niya, the Laplace equation would hold. And by the uniqueness Laplace equation would hold, that would mean that yung boundaries nito, yung boundaries niyan, yung local maximum nun at local minimum, nasa boundaries lang. Local max at min. Again, nasa boundary lang. Kapag nag-hold yung Laplace equation mo at boundary. Okay? And since yung boundary mo nga is V naught. Okay. And then, ito na yung max at min mo. Dahil ito yung nasa boundary. Okay? And this tells us that at inside, iba yung color natin, inside V is V naught also. Okay? By the uniqueness theorem. So tama tayo na potential is constant inside. Kasi sa boundaries pa lang, constant na yung potential. And by the uniqueness theorem, constant na din dapat yung load. Okay? Again, dahil yung local minimum at maximum mo, malalaman mo lang sa boundary. Okay? Okay? Okay. So sa libro, medyo mahirap siya intindihin. Pero ayun yung point. Given ka ng boundary, okay. Fortunately, yung boundary natin ay constant. So dapat, ito na yung maximum at minimum. So yung solution sa loob will be just one, which is unique, which is this constant. Okay? Now, meron tayong corollary, basahin nyo na sa libro, na same lang din kapag merong charge sa loob ng volume mo. Okay, so the potential in a volume V is uniquely determined if meron kang dalawang condition na satisfied. Okay? Sa unang statement niya, ito lang yung binigay sa'yo. Yung value of V on all boundaries are specified. Okay, so pag nalagyan mo na siya ng charge ngayon, dapat alam mo yung charge density throughout the region. Okay? Okay. So, yun lang. May additional kang requirement if meron kang charge sa loob ng boundaries mo, ng V mo, sa volume mo. Okay? Okay. Ito lalo mahirap na thing. Okay, so yung pangalawang uniqueness theorem is about electric fields naman. Okay? So suppose you're in a space. Okay. Gawin natin rin. Gawa muna tayo so meron tayong mga conductors. Meron tayong mga conductors na arbitrarily shaped, C1, C2, C3. Okay. Ayan. Okay. And then it's all living in a space that is covered with a charge density rho. Oops, mali. Dapat red. So it's all living under a space that has a charge density rho. Okay. Rho is equal to Rho is equal to something. And meron tayo. So there is rho. Okay. Now the uniqueness theorem tells us that in a volume V surrounded by conductors and containing a specified charge density rho, the electric field is uniquely determined if the total charge on each conductor is given. Okay? So malalaman mo lang yung electric field E can be known and is unique. Kapag total charge is specified. If you know the total charge. Okay. Okay. So we prove this again by disproving it. Okay. So punta tayo dito. Let's say na aalamin natin yung area. Aalamin natin yung field at this point. Okay. Sabihin ko ngayon na there is two fields here. Okay. Yung arrow ay tinututok ko lang sa ganyan. Not necessarily the direction, no? Sabihin ko lang na at this point, meron siyang dalawang electric field. Okay? Bali, sinasabi ko na hindi unique yung sagot dito. Okay? Kasi parang hindi naman unique yan. Daming nakatutok sa kanya na electric field. May electric field to, may electric field to, may electric field to. So baka hindi to unique. No? Sabihin ko na dalawa yung electric field at that point. Okay? Okay. So let's try to write down what these electric field are. So I know that the divergence of E1 should be equal to rho over epsilon naught kasi meron ka rho all over the space. Meron kang charge density. And then rho over epsilon naught din. Okay? So this doesn't tell me much, no? So sige, subukan natin na kunyari by Gauss's law, kaya ko itong malaman. Okay? So by Gauss's law, kuha ko ng surface. Okay. Kuwari, malupit ako mag-Gauss's law kahit hindi symmetric yung bagay ko. Malalaman ko yung area. Okay. So hypothetically, we can write that down as the closed E dot dA. Okay? That dA must be equal to that Q C1. Okay? So the charge along C1. Okay? Okay? So C1 yan. Na-enclose ko si Q. Okay? So yung total charge na may enclose ko at that area. Then consequently, I can make my boundaries very large. So this is enclosing C1. Consequently, I can do, sorry. Mamaya pala yan. Pwede ko rin pala malaman yung electric field dito gamit tong, again, malupit ako mag-Gauss's law. Theoretically, I can do this. No? Kuwari perpendicular lahat ng points ni C2 towards this surface. Then I can write actually medyo magulo yung ano yun. Sorry. Huwag niyo pansinin tong boundary na to. Kunin ko rin pala si E2 gamit tong points na to. Kasi sinasabi ko dalawa yung solution. So, I have C1, E1. This time, this is E2 at dA. Okay? Okay, so C2, C1 pa rin. C1 pa rin. Sorry. Karito, di ba? Okay, so all about C1 to. All about this conductor. So, sinasabi ko kasi na mayroon dalawang solution at this point. So, una, try natin kuhanin yung divergence nila. Then, ngayon naman, ginamit ko yung Gauss's law to find out this guy. Okay? Okay? And then, I can expand things. No? I can expand things na all space. Kuwari, matindi talaga ako mag-Gauss's law. I can do this, E1, such that Q total. Okay? And another one, for the solution, E2. Okay? So I'm trying to disprove na hindi unique yung sagot. And this is Q total. Top na lang. Okay? So yung Q total will just be QC1 plus QC2 plus QC3, etc. Ayun yung Q total na. Okay? Okay? Okay. Medyo clear pa naman yun yung mga Q mo galing sa charges. Okay? And then, again, yung trick dito is hanapin nyo kung ano yung difference ng dalawa. Siyempre, titingnan natin kung gaano kalayo yung mga sagot natin from E1 and E2. So we have E3 must be equal to sum Define to, dinedefine ko si E3 as some difference of E2 and E1. Okay? And then, if you can see, if I get this, then I'll be just getting the divergences of E2 minus E1, E1. And we know that from what we solved earlier, these are the same. Rho over epsilon naught minus rho over epsilon naught equals 0. Okay. Okay, so pwede ko rin naman i-Gauss's law na integral. Pwede ko integrate si E3 at TA. Okay. And then I'll integrate the others too, which is E2 minus then minus integral ng E1. Okay. And this is just QC1 for conductor 1. And this is just QC2. C1 for conductor 1 din. Okay. So this is just 0. Okay. I can do this all for all C. Pwede kong ulitin yan this time around C2 naman. Tingnan natin contribution ng conductor 2 and makapansin natin same lang din. Okay. This tells me that at this point, isa lang dapat sagot. Okay. Kasi kung mapansin mo yung mga divergences nila and yung Gauss's law, nag-equal lang. Okay. So the solution must be unique. So yung sa Griffiths sa libro, medyo mahirap yung discussion, pero you can read more about, okay? Gagamitan niya ng potential. Pero ang point is, kailangan mo malaman yung charge density rho and charge total charge on each conductor. Okay? So meron tayo example sa libro. Let's say na, kunyari, I have this. So meron akong charge. Conductor to, conductor na bilog, which contains Q. Then I have this Q minus. Then I have another one here at below minus. That's another one here plus. And again, this is negative Q and this is Q. Okay? Okay, so anong point ko? So yung uniqueness theorem, itong second uniqueness theorem, makikita natin dito na kuwari pagtabihin ko tong dalawang to. Pagtabihin ko yung dalawang to. So cute, di ba? Okay, so itong tingnan natin to. Makakakuha ko ng charge distribution row dito. Alam ko yung charge distribution row. Tama? Okay? So pero hindi natin alamin. Ang point ko lang is, tatanungin ko kayo. Pam, are you there, Pam? Mag-attract ba itong dalawa? Magre-repel? Si PJ, are you there, PJ? Okay, PJ, anong mangyayari dito? Mag-attract ba sila or magre-repel? Attract. Okay, tama. Di ba mag-attract? Opposite charges attract. Okay, that's that's very intuitive pa naman. Okay, now what we can do is tingnan natin. Okay. So I can find the field elsewhere, di ba? With this information, I can find the field elsewhere. But however, let's do this. Kunwari, maglalagay ako ng conductor, ng wire that connects them. Okay? That connects them. Now, we may think na this is kind of stable kasi this is close enough para ma-attract yung negative at positive. Okay? So, sabihin natin na since this mukha tong stable, no? Parang may electric field ka na pa ganun. Electric field ka pa ganun. Okay. Di ba kasi malapit sila, di ba? Mag-attract sila, di ba? Okay. Tapos dito naman, para kang may electric field dito. Electric field dito. Ngayon, paano kapag tumayo ka somewhere here? Pag tinignan mo ngayon, hala, di ba dapat neutral yung mga bagay-bagay? Kasi this is a conductor, tapos may positive and negative. Then the total charge in the conductor must be 0. So dapat yung electric field mo, 0. Ang nakikita niya, dapat 0 to. Kasi neutral yung setup mo. Tapos dito may sinasabi tayong electric field kasi nag-a-attract. Okay, so ito yung purpose ng there's an electric field here. Yeah. So ito yung purpose ng second uniqueness theorem. Okay? So which is more logical? Ang logical na mangyayari is kailangan mo mahanap, again, the second uniqueness theorem mo. Anong definition? What is the total charge on each conductor that is given? The total charge, wala yung drawing. The total charge in each conductor, kasi sinasabi natin conductor to, given to na conductor itong dalawa, kinabitan pa ng wire, then this whole thing is a conductor, and the total charge on this conductor is 0. This guy, Q tot, 0. And this guy, Q tot, is 0. Okay? So the reasonable answer for this setup is that E should be 0. And this is unique. Ito lang dapat ang sagot. Hindi dapat to mag-exist. So ano mangyayari ngayon sa conductor mo? So yung conductor mo, ang gagawin niya is i-dissipate yung charges along its length, along its shape, para maging neutral siya. Kasi ito ay plus Q and this is minus Q. So in essence, magiging neutral dapat yan and dapat magiging neutral itong mga to. Dapat walang charge dyan. Walang mabubuong field dito. Okay? Okay. So ayun ang uniqueness theorem. Medyo malabo pa siya for now. You can read it more about it. Pero ito, kailangan natin to sa mga techniques na gagawin natin next week. Okay? So mga next week, maghahanap tayo ng potentials, yung mga trick in finding the potentials without integrating. No? Hopefully without integrating. Or mas madali dapat yung integral. Okay? Kasi dito wala pa tayo na pala. Ang right-hand side mo, potential din. Yung left-hand side mo, potential din. So kung hindi mo talaga alam yung potential, hindi mo ito masasagot. Okay? Okay. So ayun, that's for your uniqueness theorems. Again, your uniqueness theorems tells you that given these boundary conditions, given that these situations are satisfied, then yung field or yung potential mo is uniquely determined. Okay? Isa lang yung sagot. Kung ayun na yung logical na sagot, ayun na yung sagot talaga. Wala na. Diba? Okay. Are there any questions? Kung hindi nyo pa nagigets ngayon, that's okay. Explore natin next week. No? Kasi mamaya pag binasa nyo, lalo magulo. Pero ayun lang yung point nito. So, any questions? Okay. Both E and V po ay unique, sir. Okay. Unique lang siya kapag satisfied yung ito. Okay. Yung potential inside a volume is unique kapag nalaman mo yung potential on the surface. Yung electric field, unique siya kapag these are satisfied. Alam mo yung charge density at alam mo yung total charge on each conductor. Okay? Okay, so anything else? Any questions? Kung wala na, that's it for today. Walang prob set. Pahinga tayo. Okay, stop ko na yung recording.